Alright, welcome everybody to week 3, day 1. I just played a little bit of Black Sabbath before class, and naturally the message of the day is a dragon telling me that I have no real enemies. So, pretty cool. I don't know. Apropos of something, I'm not really sure. So what we're going to talk about today is more proper class design. We're going to talk about operator overloading in C++, which hopefully you've done through Zybooks, but we'll talk about it. And we're going to talk about the rule of 3, which is from your upcoming Zybooks, which will be due next Monday. Make sure you do the Zybooks. Like, when I lecture, you will be, like, it helps to learn the material in different ways from different people. I always present what I consider to be the most important parts of C++, but there's a lot of nooks and crannies in C++ that some of you might have realized from my review of C++ in 2 hours lecture, where it wasn't really exactly a review because there's a lot of things in there that you probably hadn't seen before, like unsigned integer 16-bit underscore t, and things like that. So yeah, so we're going to continue our discussion of classes, and today we're going to build on what we did, was it last Friday, with the vector2d class. So remember, a vector2d is basically a point in Cartesian space, right? So we can make a point like this, and we can add them to a vector like this, and we can print out all the vectors like this. And the reason why this works is because we have a double left arrow operator defined on it. If we did not have a double left arrow operator defined on it, right here, it would not know how to print it to the screen. So if we wanted to sort this vector, it won't work, because C++ does not know what you mean by less than, right? Because the sorting function works by comparing two elements against each other and then being like, all right, this one's less than this one, so put it first, and this one's bigger. So how exactly sort works doesn't matter. We just need to know that it does. So sort vector.begin, vector.end, like that. And will it compile? Nope, it will not compile. And the reason why it doesn't compile is because we have not told C++ what it means for one vector2d to be less than another. And so we need to define that. So sort requires the less than operator to be defined. So the less than operator is the single most important operator in C++, simply because we sort things so often. Like, for example, if you want to do the Voronoi calculation, Tony Yomi has different Voronoi sweep line algorithm. Basically, you have to take all the points, sort them from left to right, and then you run this algorithm on it where you basically find this person, and then the line kind of sweeps this way, and yeah, it's a very common thing. I've got books of computational geometry over here, and it's quite common to sort the points left to right or top to bottom, or however you want to do it. So in order to do this, we need to tell it how to sort, because it doesn't know by default. It doesn't know if you want to sort by x, by y, greater than, less than. It doesn't know. So you got to tell it. So let's come up here to the vector2d class, and we are going to make, there's a couple different ways you can do this. Whenever you use operators, most two parameter operators can be written in two ways. As a member function, or as a global function. So I'll do it as the global function way first. So Boolean operator less than, and it'll take in two vector2ds, so 2 points. And we're going to tell true if the first one's less than the second. That's what we're doing here. Okay. So const vec2d by reference left hand side, const vector2d by reference right hand side. And so if we want to sort it left to right, then we're going to be sorting on x. So if we want to sort from bottom up, we're going to be sorting on y. Just kind of depends how you want it to be sorted. So I'm just going to say if the left-hand side's x is less than the right-hand side's x, return true. If it's greater than, we're going to return false. And if they're equal, that's just... I don't need an else here because it's returning, right? Otherwise, then we will sort on y. So y2y and paste. No, actually, let's do this. To do the simplest way of doing this. So if LHS.y is less than RHS.y, it returns true. Otherwise, it returns false. So this is, we don't need to worry about equality because if they're equal, it's not less than, right? So that is a valid way of making a less than operator. So it's going to basically says sort points left to right by their x values. And if there's a tie on their x values, it sorts, if a tie, sort bottom to top. Would the else slow the code down if included? Nope, but it's not necessary. It's extraneous, and I don't like writing extraneous. All this would be the same. The reason why we don't need it is because if the if statement is taken, it returns from the function. Right? So if it returns from the function, it can't do both. Right? So anytime you have a return statement, else's are not needed. Right? Think about it. You can't do both. So there's an implicit else with each one because it's returning each time. It can't go on. It doesn't slow down anything. It'll generate the exact same code, but I just don't like having extraneous words when I don't need it. Question. Yeah, it's not. This isn't a place of optimization. It's just there's a principle that most people don't know about in computer science, and this is one of the reasons why I get into arguments with people over using namespace standard. But everything you put on the screen eats up your mental bandwidth, right? The brain has a limited ability to look at symbols on the screen and parse them and interpret them. And when you put a ton of extraneous things on the screen, stood colon colon, stood colon colon, stood colon colon, else else else, stood colon colon, stood colon colon, none of which does anything. It actually slows down your mental ability to write and read code. So, and you'll never see that in the discussions of using namespace standard. Well, it doesn't bother me. Well, it does. Like if you one of the professors in my department actually added eye tracking to people writing code, and you'd watch where people's eyes were going, and they glance at every symbol, right? Like it eats up. You're not aware of it because your eye movement, the saccades of your eyes are subconscious, but it eats up your bandwidth. And if there's no reason for it, it doesn't contribute anything. Like I said, I've been using namespace stood forever, and it's once caused me a problem, and it was a compile error that I fixed in a second. Like, you know. Okay. So why are we comparing left-hand side and right-hand side again? We want to see which point is less than another. So this, by writing an operator, we can say if, let's say we've got 2 points, like we got vector 2D A, which is equal to 0, 10, and a point B, which is at negative 100, negative 200. This allows us to write code that says if A is less than B, then C out, whatever. Okay. That's what an operator does. Every time you do a plus or minus or less than or a greater than or whatever in C++, it's actually calling a function called operator plus or operator less than or operator double left arrow. So when you say C out double left arrow A, when you write this code, this is exactly the same as saying operator double left arrow C out A. It's exactly the same thing. I don't know if that would compile, but it's exactly the same thing. Okay. So it's like you're calling a function with the name operator, like literally typing out the word operator, then the symbol. So if you wanted to make a plus operator, like to add 2 points together, by default this won't compile, right? Because C++ doesn't know how to add 2 vector 2Ds together. But what it's doing when you do that, it's like if you want to do that, you have to make a function called operator plus that takes in a vector 2D and a vector 2D. And if you make that function, which should probably return a vector 2D as well, if you make that function, then C++ will in fact compile this code. Okay? So that's what's happening behind the scenes. Every time you have a plus or minus or double left arrow or less than, it's actually just calling a function. And all the primitive types, all the built-in types, have functions made for them already for plus and minus and divide and modulus. And strings have a plus operator. They don't have a minus operator, but they have a plus operator, right? So when you plus 2 strings together, it adds them together. Hello plus world gives you hello world, right? So it's not program optimization, it's brain optimization. Yes, exactly. And that's something that I'm really passionate about, and just the entire computer science education industry neglects entirely, as far as I can tell, outside of perhaps the software engineering research people who study this kind of stuff, like what makes you productive as a computer science major, what makes it possible to learn computer science, what makes it possible to produce code that's readable, what makes it possible to read code and quickly understand what's happening. Like legitimately, like I would say 95, 99% of people just never consider like the brain aspect of programming. And remember, code is for people. Code's not for computers. You know? To the computer, this would be the exact same function. Right? It's a lot less readable now, right? But it's the same function. White space doesn't matter. Right? And if I wanted, I could go through and delete even more white space and just make it absolutely unpalatable to human consumption, you know. You know what I mean? Like I could just make it a solid block of like symbols, and yet, you know, somehow people don't write code that way, right? Like they sort of intuitively understand that code needs to be clean and readable, but they don't understand why. You know, it's my take on it. So so the less than operator not only allows us to write code like this, where you can say if one point in space is less than another, it also unlocks the power of sort, not salt, sort. Okay. So the sort algorithm requires you to have a less than operator defined. That's why I call operator less than the queen of all operators, because it is the single most important operator to write on your class, because we want to sort things so often. And in fact, if we do this and then print the vector again, g++ main.cc, run it, you'll see that I should probably do it before and after on it, huh? Okay, see out. Yoink. So here's the before, here's the after, and you can see that it is sorted with the x value first, and then the y value second. Okay. Maybe I should put these two in a different order. So yeah, you can see that it was 11 and 10, now it's 10 then 11. So it sorts left to right, and then bottom to top. Very useful for a lot of anytime you're working with space and geometry and things like that. It's very common to just start by sorting the whole thing, and then it just makes a lot of your algorithms a lot simpler. Okay, less white space is faster to type. Yeah, but you know, you start running into like the human eye looks at words, right? And so if you take out spaces, then there's not separate words, and so it becomes one word, and then you have to parse that word apart, which takes more effort. So, okay. The reason why we need to create a bool operator less than is because we don't have include algorithm. No, we have included algorithm. That's been in there since the beginning. But if we don't have this function, it doesn't know how to sort it. Sort will work on all the basic types, because all the basic types have operator less than defined on them. So it knows how to sort. It knows how to sort ints and floats and doubles and things like that. But if you make your brand new type right? Like, let's say I just, right now, just make a new struct called point, and it's just got a x and a y, like this. C++ has no idea how to print this to the screen, has no idea how to add two of them together, it doesn't know how to sort them, it doesn't know anything about it. This is just a variable that's got two sub-variables in it. None of the plus, minus, multiply, divide, none of those things will work on it, right? If I try making 2 points and then say a is equal to a plus b, doesn't work. There's only one operator that it will make for you, and that is this one. So C++ makes for you an operator equal sign for free that just copies all the elements from one to the other. So if we say A is equal to 10, 10, and B is equal to 20, 20, set A equal to B, and C out A.x and B dot A dot Y, then you'll see that when we print out A, we get 20, 20. That is the only thing that C++ does for you for free. And there is also a copy constructor, which is very similar to the equals operator. So this is the only one it does for free. Okay. Yeah. Okay. And if you want to not have that done for free, you can do this. Let's see here. Int. Let's see here. Void operator equals const point right hand side equals delete. So if you do that, remove the one it makes for you. So then this doesn't work. Okay. Or if you want to make it explicit, you want the default one, you can write this instead. Okay. So that makes it clear, hey, I want the default equals operator. And I think this is actually should be returning a point like that. I rarely write that because I just leave it as the default. So what are we mad about here? Explicitly defaulted must return a point reference. Okay, whatever. Yeah, I don't ever use this because there's no point. But if you don't want it to make one for you, you delete it, and then this doesn't work. So does this? There is no final keyword in C++. That's a Java thing. Okay, so do you guys understand the motivation for all this here? So like we've made a class, it's a point, and we want it to, you know, like sometimes we want to print them to the screen with double left arrow, sometimes we want to add them together. And so for every single one of those things you need to do, you need to make a an operator for it. So like if we want to add 2 points together, then we can make a operator plus that takes 2 points. I'll use the global version again, like this. So const point left hand side, const point reference right hand side. So if you want to add 2 points together, if you guys have ever taken linear algebra, the two x's add together, the two y's add together, and then that's point return value is equal to its x value is equal to the left hand's x plus the right hand's x and the left hand's y plus the right hand's y. So, you know, if you have the point 10, 10, and you add to it 20, 30, you end up getting 30, 40. Right? If you haven't had a linear algebra, well, that's how it works. They were done physics, and you have the vectors, and you like add the two vectors to each other, right? Like you have a force going this way and a force going this way. You take the tail of one and put it at the head of the other. That's that. Okay. And if you do this, then you could say now a is equal to a plus b, and it compiles. The equals operator is done for you for free, and now we've got a plus operator. So we have now told C++ how to add 2 points together, and it knows how to do an equals. And so, okay, if we do this, we'll get what, 30, 30, 30, A little different. Make it 3210. 3210. So basically, if you want your classes to act like built-in types, you've got to overload all the operators that it makes sense to overload. Okay? So, now they don't always make sense. Like, what does it mean to like modulus one point with another? No, it doesn't make sense to me. You know, and C++ won't compile it, obviously. Like, no, I don't. No. You know what I mean? Like, it doesn't make any sense. And this brings me to one of my big points when dealing with operators, is that we use operators to make usually mathematical types act like math, so you can add them and subtract them, and you know, for your next homework assignment, you're going to be doing fractions. You can add two fractions and multiply two fractions, and some people went way overboard, especially back in the day. They went way overboard with operators, and so like I saw this one database program that used they overloaded the plus operator to do inserts into the database. They used the minus operator to delete things from the database. Multiply, I don't know, added columns to a table, and modulus, like I don't know, printed it to the screen. Like it made no sense to me whatsoever. And so they create these giant like algebraic equations, and what was happening was like it was inserting and deleting and querying, and it just, I was like, oh, like no, don't do that, And that's actually why Java got rid of operators. There's only a single operator in all of Java, and that's plus for strings, because everybody likes plussing strings together to add them together. So if you have hello in a string and a world in a string, you plus them, it becomes hello world, right? That's the only operator allowed in all of Java. They made a special exception just for strings. In no other case can you overload an operator in the language. And they did that because people went bananas in C++. Nowadays, it's considered bad practice to do that. Like, if I were to make a, I don't know, plus operator for circles, like, I don't know, what do you guys think? What would it even mean to, like, add two circles together? You know what I mean? Like, anyone, like, do you have any ideas? Like, we're going to add two circles together. Cylinders? Oh, still. No, that'd be like a circle times a scalar or something. I kind of like that. Yeah. Adding the areas together. Okay. I guess we can do that. The areas. How do you add the areas? We have a radius and a center. It's like add the radii together. Yeah, I don't know. I got nothing. Circle squared. It literally makes no sense. And so, like, don't do this, right? Right. So circle temp dot radius is equal to my radius plus the right hand side's radius. So we're making a circle whose sum, and my center is equal to the average of the two centers. I don't know. Center dot x plus their center dot x divided by 2. It's kind of hurting my brain writing this. And okay, center dot y plus their center dot y. So, like, the center point's going to be averaged together, and then the radius are going to be added. Like, I don't know. Like, this is so horrible. For the love of all that's holy and sacred, don't do this. Okay. And return temp. Okay. So, if you did this, and after you clear the vomit out of your mouth, like, you do this, I don't know, circle Bob equals radius of 5, and the center point is at 10, 20. circle Pablo has a radius of 10, and he is at negative 10, 20. And then if we say Bob is equal to Bob plus Pablo, the plus operator is now defined. The equals operator you get implicitly. And then we can see out Bob, because we have the double left arrow operator already written for circles. Whew, didn't like that. Maybe we don't have it defined for circles. Okay, we don't have it defined for circles. So let's do it for circles. So friend OStream. This will, again, look like hot garbage. It's just a pattern that you get used to. I'll call this one left-hand side to be consistent. And circle. So I'm telling it how to print a circle to the screen. Okay. Invalid use a non-static. Yeah. Right-hand side out radius. Because when you call this, you're going to do something like this. Like you're going to go see out Pablo, right? And so the left-hand side of the operator, right? Most operators take two parameters, right? A left-hand side and a right-hand side. The left-hand side is on the left-hand side of the operator. The right-hand side is on the right-hand side. So this is a function named operator double left arrow, right? Is the name of it. It's a every function. Every time you do a plus or minus anything, it's calling a function literally called operator that. In this case, operator double left arrow, and it's passing in two parameters. It's passing in cout, and cout is of type output stream, like that. Again, it's going to return an output stream. That's what allows you to chain things together like this, right? Because when you do cout Pablo, that returns cout, and then it can cout the inline. That's why we return. That's why we return an O stream. To chain those things together like that. And then when this function's called, it's going to print Pablo's radius. Then it prints a space and a open parentheses. Then it prints out Pablo's x value, a comma, Pablo's y value, and then a close parentheses. So if we do this, it now prints. There it is. So the radii were added together. I don't know why. Barf. And you can see the positions of negative 10, 20, and 10, 20 were averaged together to give you 0, 20. So, yay, we can add circles. Don't know why. Okay, so, but for things like points and things like that, super useful. Now, like I said, there's two different ways you can do. There's two ways you can do. Where is it? As a member function or as a global function, right? So this is the global function version. We could do it as a member function like this. And oh no, actually that's a global as well. Let's see. Let's make it a member function. So a member function is exactly the same as a global function, except the left-hand side is implicit. So you're actually when you do the member function version, what you're doing, like if you say, if you're saying if A is less than B, this is the equivalent to if A dot operator less than B is technically what's happening here. It's actually calling A dot operator less than B. It just looks nicer. Okay. So you're actually calling a member function on A. So A is having a function called on it. That's why we can just say x and y instead of LHS.x. Right? You still have the right-hand side passed in. That's that. But if you used a global function, it would call this global function passing in A as the left-hand side, B as the right-hand side, If you do it with the member function route, then these two things are exactly the same, by the way. It's just a preference as to which one you like. I have really no strong feelings on it. I've kind of come to a point in my life where I don't like global functions like this anymore. Like, I kind of like them all bundled up inside of the class itself. So I'd probably do it like this. Or I would take u and paste it in here and make it a friend function. And so this is and there should be a construction. So these two things are exactly equivalent to each other. Okay. So, yeah, I should explain what this is. So if you're ever going to do like a giant less than operator, or a giant less than, yeah, that's comparing all sorts of different things. Like if you wanted to less than a circle with another circle, you'd have to write like a lot of code, right? Like you want to sort first based on the x location, then on the y location, then on the radius. You end up having to write these giant if, else, if, else, if, else. If the first one's x is smaller than the other, return true. If not, if it's a tie, then you do, and it gets like kind of like ugly and verbose. There's actually this very clever thing that I only found out about it a couple of years ago, like probably 4 years ago or so, when I was at 5 years ago when I was at CPPCon. I just saw a guy just kind of offhandedly writing his less than operator that way, and I was like, wait, what? You know, like, wait, what? And what this does, the tie function here, it creates a temporary variable that has a less than operator defined on it that compares the first elements first, then the second element second, and the third elements third, which is exactly what we want. You know, when we're doing this, it's just it's already done for you basically. So by tying these three variables together, you get a free less than operator defined on it, and then you can just do that, and you don't have to write all this kind of code. So it's tie part of the standard library. It is, and it is in the tuple. Yeah, and I've got two operator less thans now. I know. So I need to pick one of these. So just randomly pick this one. Then, because they're exactly the same. You saw that. It's like it's ambiguous. I don't know which one you want. Because that's how similar they are. It won't even allow you to have both options in it. Actually, I'll keep the version with tie. Okay, just because it's one line. Yep. So tie is part of the tuple library, if you want to include that. Will this file be in public? Yes, it will. It will be in public. Okay, so basically, yeah. So what we've learned today so far is if you're making your own type, you can make operators for it, right? So if you want to add circles together, why, I don't know, but if you want to, you can add them. More realistically, though, like if you're making a vector library, right? You're doing physics or something, then it does make sense to want to add them or to scale them. Like if you want to take a point and multiply it by a value, for example, vec.at 1 times equals 10. Vector.at 1 is this one, right? X is equal to 1, y is equal to 10. This should conceptually scale it 10 times, right? So it should become 10 comma 100. A very common thing in vector math to scale things, right? You increase the velocity by 10, you know, whatever. But it's not defined, right? Because there is no times equals operator. So let's make one. And you're like, wait, am I going to have to do this for plus and plus equals? Yep. Plus and plus equals are they're two different functions. Okay. So, friend, this is we can make it void, I guess. Operator plus equals, and it will take one parameter, right? Because we're the first one. So it's going to take another vector. No, it's going to take an int, right? Int. Right-hand side. So my x value gets multiplied by the right-hand side, and my y value gets multiplied by the right-hand side, and we're done. Is it not like that? Must have at least one parameter of class. Oh, it's a friend. Right. For the left-hand side, because we're doing a global. Vector 2D left-hands by reference, left-hand side. Left-hand side dot x, x dot y. Okay. So this is teaching C++. If you have a vector 2D on the left-hand side, you know, for example, if you have vec 2D bob is equal to 510, and then you say bob times equals 10, bob is now 50, 100, right? Oh, this plus equals, shoot. Times equals. Makes a little more sense. Okay. Does void do something different than ostream? Ostream is the type of cout. So this is a function that is returning cout, basically. This is a function that is returning nothing. So you can't say like cout bob times equals 10, because that won't, because the times equals doesn't return a value. I suppose we could have it return the vector 2D if we wanted. I've never seen people chain together times equals. So Rodriguez Cruz, do you understand what a void function is? Like it's a function that just doesn't return a value? Okay. So, yeah, like an operator less than returns true or false. That's why the less than operator returns a bool, right? Because it returns, you take two vector 2Ds, and which, is this one less than this one? Yes, true. So that's why it returns a true or false. For a double left arrow, it returns an O stream, just cout. Times equals returns nothing. I mean, I've seen people have it return vector 2D, but I've never seen that used in practice. All right, so now if we come down here and do that, it works now. And so when we cout it, the second element is going to be 10, 100. See the difference? So that guy there got multiplied by 10. And then when we sort it, it's now here. Okay. That makes sense to y'all? So like basically every time you want to teach C++ how to do math, how many operators are there? There's like 60 or something like that. And the syntax is a little weird. Yeah, but you do the weird syntax up there so that the syntax down here makes sense. Right? Like you've got a point and you're just going to scale it by 10. Quite readable, right? Makes sense. Cognitively it makes sense. This makes no sense. So don't do that. Don't write code that way. Right? This makes sense. And so basically it's literally a function named operator and then times equals. On the left-hand side, it takes a vector 2D. On the right-hand side, it takes an int. And you have to do this for every possible operation that you want to support. Plus, minus, times, divide, modulus. A square bracket is an operator. You can overload square bracket. So like if we wanted to do the square bracket operator, let's do the member function version here. Let's return a float operator square bracket, taking in a size key index. So what if we had a vector 2D bob and we wanted to just cout bob square bracket 1? What about that? Right? So bob square bracket 0 would be 5, and bob square bracket 1 would be 10. Right? You could do that. Easy as pie. So if index is greater than 1, then die or throw. Time error. Vec 2D has 2 elements. index equals 0, return x. If the index is 1, return y. Otherwise, throw an error. Okay. Kind of cool. So now, point A, point A. Okay. Let's get some point things here. Okay. So cout vector dot at 1. Yeah, this is terrible. Let's make it vector 2D bob equals 30, 40. Cout bob square bracket 0. Bob square bracket 1. Didn't compile. Oh, I forgot. Bob already. Dang it. No. Okay, let's just delete our circles because we don't need them right now. Okay. There. Guys, see how easy that is? It's pretty easy. And so you can make your types act like mathematical objects, you know, or you can make them act like arrays, right? All of a sudden now the vector 2D you can actually use square bracket on and treat it like it's an array of two integers, or two floats technically, right? Does that make sense? So yeah, there's like then there's all the comparison operators: less than or equal to, greater than or equal to, and not equal to. And there's something called the spaceship operator, which is introduced in C++ 20. That's which is like auto operator that. But don't worry about it for now. Okay. You guys like this? It's tight. It's even doing balance checking technically, right? So if you try scouting Bob, 10. Vector 2D has 2 elements, dude. So can't even go out of bounds. No, but yes. So what do you not understand about this, Portnoff? They give you a bunch of trouble in Zybooks, yeah, but we're talking real life now. This is what you have to do for your next homework assignment. Yeah, so you are going to get practice doing it, Otal. So let's take a look at the Fractionation. So fraction.h. So you are going to be making a fraction class, and fractions have certain operations on them, like plus and minus defined. I've already done a lot of the stuff. There's a default constructor that sets it equal to 1. Why 1? Why not 0? What is 0 over 0? Division by 0. Yeah, so I avoid that by just initializing to 1 instead of 0. Your next Zybooks is up, by the way. It's due next Monday. Make sure you're on top of the ball with those things. This class is a lot easier if you actually put in the time and the effort to do the Zybooks and get them all done on time and do the labs and stuff. Is the do not file being edited? You can't make a file right now. Don't edit the do not edit file. I don't know why you can't edit it. Okay, so so the first thing you should do in this assignment is to do the double lift arrow operator. That allows you to actually echo fractions to the screen. Otherwise, you're gonna have a hard time telling if any of your stuff's working, right? The double right arrow operator is done for you. We'll talk about reduce in a little bit. The plus operator is done. This shows you how you can add 2 fractions together. Okay, and that's why I do my code this way. I kind of scaffold it for you, so there's example code, and like Mr. Bell said in the last class, looking at existing code and adapting it is one of the best ways of learning, and even in professional practice, doing coding. You find somebody who's done something similar to what you've done, and you adapt it to your needs. But you need to understand it, right? You have to understand what's going on here. And so when you add two fractions together, you have to find the common denominator, right? If you add 1/2 and 1/3, the common denominator is 6. So you convert 1/2 to 3/6. You convert 1/3 to 2/6. You add them together. The numerator is 2 plus 3, 5. The denominator is 6. And that's what's getting returned here. Okay. And if you want to simplify that, you can actually you actually don't even need to make a temporary value like I did, and I think I did earlier as well. You just do that. So you don't need to make a temporary value and return the temporary value. You can actually just return directly using curly braces. A little less code. I typically split it into 2 different lines for newbies, so they can kind of understand, okay, so it's making a fraction, and then we're returning that fraction. This does the exact same thing, because we're returning a fraction. We know the return type is a fraction, so when you return a value, it gets cast to be a fraction. And so the first parameter is the numerator, second parameter, denominator, works just fine. Okay. So, is there a way to test if you're doing it correctly? Yeah, there's an input tester, sure. Absolutely. So the first thing you need to do, though, is do the double left arrow operator. Otherwise, everything that you output is going to be omae wa mo shinderu, right? So then do minus, multiply, divide. Those are all pretty straightforward, I think. If you just look at how plus works, you can figure out the other ones. Multiply is even easier than plus because you don't need to do a common denominator. Double equals works. Comparison, the lesson operator, is very similar to equals, right? And so when you compare two things, you have to convert to a common denominator and then look at the numerators, right? Same thing for less than. Convert to a common denominator, look at the numerators. Okay. Now, before we get to decompose, let's talk about reduce. So when you reduce a fraction, you have to find the greatest common divisor of the numerator and the denominator, and then divide by that. So 5/10, the greatest common divisor is 5, so you divide the top by 5, the bottom by 5, you get 1/2. That's it. There is a stood GCD function. Should we use simplify? No. You only simplify, you only reduce when told to. Okay? So the only time you reduce automatically is with the decompose. Okay. So for the multiply operator, there's only one parameter. How do we multiply the fraction parameter with another fraction? Where would the other fraction come from? That's the member function approach. Remember, there's 2 ways of doing operators. One is the global function, where it takes 2 parameters, the left-hand side and the right-hand side. And then when you have a member function approach, it takes 1 parameter. You see the difference here? The member function approach has 1 parameter. The global function approach has 2 parameters. The reason for that is when it's a member function, I am the left-hand side. Okay? So I just say x, and that means my x. I could write this as this points to x, and this points to y, if you want. To be clear, it's my x and my y being compared to their x and their y. Okay. Does that make sense, Shook? This is the difference between the global and the member function, because you're calling it on a, right? You're calling a function on a person. So the left-hand side is implicit. Okay. So global, you need both, since it's not, because it's just a global function. It needs to be past both fractions if you're doing it the global function way. But when you're calling a function on an object, when you're saying a dot operator less than, this is a. So you don't need to pass it in. You can't pass it in. It's passed in implicitly. Confused on decompose. Yeah, okay, that's fair. All right. Then fraction.h. So that's the only tricky part in the assignment. I recommend doing it last. So computer science students oftentimes try to do everything at once. Bad idea. get operator double less than working first, start passing test cases, save decompose to the end. So decompose is from these ancient papyri that come from ancient Egypt. And so there were mathematicians in ancient Egypt 3,500 years ago, and there's older ones as well, that are doing really crazy, complicated mathematical equations, enough to hurt my brain, right? And so, computing volumes of cylindrical and rectangular granaries. It's 8/9 squared, d2, but there are these notions called Egyptian fractions. And so an Egyptian fraction means you break down a fraction, you decompose a fraction. That's what we're doing. Okay? And so, for example, 4/10 is the same thing as 1/3 plus 1/15. Okay? So if you simplify, this becomes 6/15. Yeah, okay. Yeah. And so what it means when you decompose a fraction is you split it into smaller fractions, each of which have a numerator of 1. Okay? And so in this case, 2/3 would be replaced with other ones as well. And so they would generate these giant tables of decomposition of fractions, and they would use them in their various calculations to build the pyramids and things like that. It's ridiculously complicated math for people who don't have calculators, right? Like it's frankly mind-boggling. And this was a textbook, essentially, the Rhine Mathematical Papyrus. And so 1,000 breads of loaves of pest food 5 are to be divided evenly into 2 heaps of 500 loaves each. Each heap is to be evenly exchanged for 2 other heaps, one of X, one. And so you're talking about like algebra, like way before there was algebra, and so a bunch of linear equations they're solving, Egyptian fractions. So basically, you break down a number into unit fractions, and that's what you're doing there. So when you do the decompose thing, and dig into that, because it's mind-boggling how hard some of those mathematical problems are. Like we're like, oh, we got computers and stuff. I still wouldn't know how to solve some of them. So what version of C++? C++ 2000 BC. Nice. So when you decompose a fraction, what you do is if the fraction's improper, you don't, when you do decompose, you don't do the whole thing. You just return one number, and that number is either a whole number that is smaller than this, right? So the biggest whole number smaller than 13/4 is 3, right? So you just return 3, and then the main will pull the 3 out and do all the other stuff. All you have to do is return either the biggest whole number smaller than the number, or if it's a fraction, you return the biggest fraction underneath it. So 4/6 would return 1/2, because 1/2 is the biggest fraction that fits underneath 4/6. Okay. 1/100th would return 1/100th. 40/100ths, which is 2/5, would return 1/3, since 1/3 is the biggest fraction with a numerator of 1 that's underneath 2/5. That makes sense? So all you do is you return the fraction, the biggest fraction with a numerator of 1 that's underneath the number. And then the main that I wrote will do the whole decomposition series for you. I didn't know this was a real thing. Yeah, it's not only a real thing, but it's something that we as a society have forgotten how to do. Like, in fact, we don't even know how they developed those fractions, because like some of those fractions are like 4 digits long, right? And so they're like 1/1010 plus 1/2020, and we're just like, how did you come up with that? When you're working on a tablet that's slate, that's literally a chalkboard. It's amazing that they're able to do it. So I wanted you guys to get some practice doing that, because I know how much you love math and hate games. So what's the third type of decomposition that results in that? Yeah, Mincarelli, apparently the person who was complaining about games works for Mincarelli, so, yeah. Zeta, Egyptian fractions, we're just going to go hardcore math this whole semester. Nah, I'm kidding. I'm kidding. Okay. So, yeah, so that's that. So let's talk about one more thing, and that is the rule of 0 and the rule of 3. The rule of 0 is preferred, and the rule of 0 says don't use new, delete, don't make a destructor, don't make an operator equals, don't make a copy constructor. That's a rule of 0. Just don't do any of it. That's what we're doing here, right? This is rule of 0. Okay. Now for the rule of 3, use if you use me. The rule of 3 says if you have a new in your constructor, you need a destructor, an operator equals, and a copy constructor. Otherwise, you will segfault, most likely. Okay, so let's switch back to Kernivec. So vim Kernivec dot h, and so this code here violates the rule of 3. And it violates the rule of 3 because we've got a new in our constructor, we've got a destructor, but we do not have a copy constructor, and we do not have an equals operator. Okay? So this code will actually segfault. It looks fine, we're newing, we're deleting, everything's proper. Sure, until we use the equals operator. Okay? So if we come over here into kernivec.cc, and we got vector 1 and vector 2, and let's do this. Let's say vec is equal to vector. Let's say vector 2 is equal to vec. Okay. What this is going to do, this is going to call the default equals operator. And it just does a plain copy. It copies over the size, the pointer, and how many elements we currently have in it. So the trouble is we now have vector 1 and vector 2, their pointers are now pointing at the same place. And so any changes you make to vector 1 get made to vector 2. And when you destruct them, they will both destruct the same block of memory, and you will get a bad time. So if we g++ kernivec.cc, I run it, we get a double free because they're both deleting the same block of memory, and we crash. Okay. And in fact, if you want to see something really obnoxiously dumb, let's do this, vector 2. So let's print out all the elements in vector 2, and, well, let's see, it's copying the size over, oh, whatever, it doesn't matter. The point is they're both pointing at the same block of memory, and so when they go away, they double, it frees it twice. And changes made to one get made to the other. It's just garbage all round. Okay, so it is a hideous situation. So compared to the ancient Egyptians, this method, yeah. Right. So we're doing the greedy method, right? They have a better method than what we're using. So they actually have a better algorithm than ours, which is terrifying to think about. Yeah, it's absolutely terrifying. All right. So yeah, the Chat Egyptian versus the weak calculator user. Absolutely. Okay, so what we need to do is not allow this. That's the easy solution, right? Like if you're like too lazy to like implement this properly, do you remember how I just showed you a while back that you could just delete the equals operator? equals, taking in a const vector by reference right hand side equals delete. You guys remember that? That's why it exists. Okay, see that? Simple. Now, in the Xi books, you're going to see about doing a deep copy, and you like allocate a new thing. You unallocate the existing array, you make a new array, and you copy all the elements over. And usually when I'm doing something like this, like 90% of the time, not 100%, like 90% of the time, I'm just like, ain't nobody got time to write that code, and I just delete the default one, and I just don't allow copying it. So if I try compiling the code now with it doesn't work. Easy peasy. So it just stops. I mean, it's like, maybe you want that to copy it, but like I just delete it. Like if it's going to crash my code, I just start off by deleting it, and then if I ever decide I really need that functionality, I can do it. But literally with something like this, I might just like, for every element in vec, I will just copy it into vector2. You guys see this? So rather than allowing vec2 equals vec, I just write a copy myself. And like I said, if it gets annoying and I'm like doing this too many times, then yeah, I'll actually make a proper equals operator. But my solution to the rule of 3 is just to, you have to do it. Like you have to have an operate equals, but nobody said it couldn't be deleted. Why do you do that? Did you not see the crash that took place before? When you allow vector2 equals vec, what happens with the default one? It copies over the pointer. And so vector is pointing at this chunk of memory, and vector2 is now pointing at the same chunk of memory. So if vector1 adds or deletes things to its array, vector2 sees those same things added and deleted to it, which is horrifying and terrible. And even worse, when they get freed, vector1, when it goes away, it deletes its chunk of memory. When vector2 goes away, it deletes the same chunk of memory twice, causing a seg fault. So I just say, nope. No operator for you, Dr. Jones. I just don't allow it. It's the simplest solution. Maybe next time we'll go into actually making a proper operator equals and a proper copy constructor, which we need to talk about too. But that's it's not an implicit pointer. They have a private pointer, and what's happening is that their private pointers are now pointing at the same thing. And so when you read and write to one, you're reading and writing to the other, which is really bad. It's really, really super bad. And so like the default thing that I do, like if I don't need, to be able to write this, which I don't, because I could just do a for loop that just copies everything over myself. If I don't need that, I just delete it. And that satisfies the rule of 3. The rule of 3 says, I don't know what happened to it. The rule of 3 says, if you have a new in your constructor, you need a destructor, an operator equals, and a copy constructor. Otherwise, your code is going to seg fault. Most likely. Okay. It's the simplest solution to it. Your textbook is probably going to say, make an operator equals and do a deep copy and deallocate your old array and make a new array and copy all the elements over. And I'm just like, You know what I mean? Yeah. Like, sometimes, like I said, it's not 100%. Like 90% of the time, I just delete it. I just don't allow it. And that stops the problems. I delete the copy constructor, I delete the equals operator, and it just stops the problem. There you go. Rule of 3. It's really the rule. Becomes the rule of 1. You have to have the destructor. You always have to have the destructor. Because every time you have a new, you need a delete. And then I just delete the equals operator and I delete the copy constructor. Unless I really need them. In which case, I'll go ahead and do it properly. Hesterberg, you understand? You see why it was crashing? Okay. So, One small trick doctors hate. Delete the automatic operator equal and copy. C++ will make them for you. And so I delete them, and then you don't get into trouble. Gonna have to look at everything again because of your brain. It's fine. We will talk more about rule of 3, I guess, next time, maybe. See how it goes. But the rule of 0 is preferred. Just no news is good news, right? My vector 2D doesn't know anything. I let the memory management for it be handled by a vector, right? So if I need things to be heap allocated and stuff like that, I stick it into a vector and let vector allocate for me. When I pop, when I push, it does all the memory management stuff. I don't do it. I don't touch it. Rule of 0. I just make a value type. What is a vector 2D? A vector 2D is just two floating point numbers hanging out with each other, good friends. And there's some operators that you can do on them, like we know how to multiply a vector times an int, apparently. It should probably be a float, I would say. It should be a float. We know how to, grab elements out of it using square brackets. We know how to see out it to the screen. We know how to see in it from the keyboard. But really, just at its heart, Vector 2D is a simple man who lives a simple life. It's just an X and a Y hanging out. Okay. Yeah, so my COVID test came back negative. However, I told people who were asking over the weekend if we were going to be in person on Wednesday, and I said no because I hadn't gotten my test results back yet. I just got them today. So I can't put it back in person on Wednesday just because I'm sure people have made plans to leave, be it shaver or something. So we will follow the original schedule, and we will be back in person on Friday, and we will be online through Thursday. Okay? So, big topic today. Make sure you've done the Zybooks on this. Yeah. Operators are oftentimes considered the hardest things to understand when it comes to classes and things like that. But don't worry. The fraction homework will help you. Do on Friday. And if you guys do badly on it, we'll do another one that does even more overloaded operators and things like that. So, yeah. Okay. Yay. You tested positive for the COVID. Congratulations. Think positive, Portnoy. Think positive. Don't threaten me with a good time. All right. Sounds good, you guys. Any questions about this? Did your respect for the ancient Egyptians go up a little bit? Sure did for me. When I was reading through the Rhine Mathematical Papyrus, I was like, what? 5 people have 4 shares of bread and 6 people have more shares, and they're dividing up 100 loaves of bread. How many loaves? I'm like, oh. Yeah, seriously. Like it is ridiculously impressive just how good they were. Yeah. Code sucks, 0 out of 10, do not recommend. They became geniuses. Yeah, I mean, the pyramids didn't happen because of aliens. It happened because they knew math, So, split the spread into picture it approve. All right, that's it for today, guys. Thanks for coming out, and stay safe, stay healthy, and I'll see you on Wednesday online and in person on Friday. Peace out.